Welcome to this explainer. Today, we're taking a microscopic look at a truly massive nationwide issue. We're going to break down the chemistry, the widespread contamination, and the incredibly complex, constantly shifting regulations surrounding PFAS, which you probably know them better as forever chemicals.
Now, before we get into the latest drinking water regulations making all the headlines lately, we really need to start with one fundamental question. How exactly does a microscopic, completely invisible threat manage to survive literally indefinitely and end up in almost half of all the kitchen sinks in America? It's wild to think about.
To figure this out, we're going to walk through 5 parts today. First, the unbreakable chemical bond. Second, forever chemicals in your tap. Third, the human health toll. Fourth, the 2024 EPA standards. And finally, the 2026 proposed rule updates. Let's jump right in.
Starting with Section 1, the unbreakable chemical bond. Why PFAS last forever.
Okay, so let's dive into this because this is where the forever part of forever chemicals actually comes from. So PFAS are a massive class of synthetic chemicals, but their defining feature, their hallmark, is the carbon-fluorine or CF bond. Guys, this is one of the absolute strongest bonds in all of organic chemistry. It has this massive bond association energy of around 485 kilojoules per mole. And you know what that means in plain English is that this exceptional energy gives these chemicals immense thermal stability and chemical inertness. They are incredibly, almost unbelievably resistant to breaking down in nature. And what makes this bond so uniquely defensive is that the fluorine atoms basically surround the carbon backbone, forming this really dense electron cloud. Think of it like a microscopic, impenetrable force field. Because of this protective shield, everyday chemical agents and biological enzymes just cannot access the reactive carbon atoms inside. Neither natural environments nor our own bodies can easily break these molecules apart. They are built like absolute tanks. Now, this robust structure directly dictates how they move through our world. PFAS have an amphiphilic nature, which basically means they have a split personality. They have a hydrophobic or water-repelling tail and a hydrophilic or water-attracting head. This unique dual nature causes PFAS to act a lot like surfactants. They absolutely love to hang out at environmental boundaries, preferentially accumulating at interfaces like air and water, sediment and water, and, crucially for us, biological membranes. So they don't just sit still, they actively migrate and concentrate. Which brings us to Section 2, Forever Chemicals in Your Tap, the USGS findings. According to a huge, comprehensive nationwide study by the U.S. Geological Survey, it's estimated that at least 45% of the nation's tap water contains one or more types of PFAS. Yes, you heard that right, nearly half the country. This USGS research was a total landmark moment. It actually marked the very first time scientists tested for and compared PFAS in tap water from both private wells and government-regulated public water supplies on such a massive national scale. By using this data, scientists were able to model and estimate contamination across the whole country, revealing a unique water quality concern that literally touches every single corner of the map. And this really brilliantly illustrates the immediacy of the problem. Just look at what Kelly Smalling, the USGS lead author, notes here. They tested water collected directly from people's kitchen sinks across the nation. We are not just talking about distant polluted rivers or some isolated industrial site. This data represents the actual water flowing directly into American kitchens, whether you're hooked up to a municipal supply or pumping from your own private well. Let's move to Section 3, the human health toll, the biological impact of PFAS. As we talked about just a minute ago, PFAS absolutely love biological membranes. So when they enter the body, they associate with serum proteins and membrane phospholipids. And because our bodies just cannot break that incredibly strong carbon-fluorine bond, these chemicals bioaccumulate over time. They just build up. The EPA notes that long-term exposure significantly increases the risk for prostate, kidney, and testicular cancers. It also weakens the immune system's ability to fight off infections, elevates cholesterol, which of course raises heart attack and stroke risks, and can cause severe liver damage. It's a heavy list. But the disruption isn't just limited to cancer and immunity either. These forever chemicals actually actively interfere with thyroid function. Your thyroid is essentially the control center for your entire metabolism, right? So chronic PFAS exposure can severely disrupt how your body regulates its most basic vital functions. The really crucial takeaway here is that while this affects everyone, the risk is definitely not distributed equally. The EPA explicitly warns that exposure is exceptionally dangerous during critical life stages. Pregnant individuals and developing babies face severe adverse health impacts from PFAS. These early developmental stages are just incredibly vulnerable to these stubborn bioaccumulating molecules.
This brings us to Section 4, the 2024 EPA standards, drawing the line at 4.0 parts per trillion.
To tackle this, the established numbers are incredibly strict. In 2024, the EPA finalized legally enforceable maximum contaminant levels, or MCLs, for two of the most widely used and best studied PFAS out there, PFOA and PFOS. The EPA capped the limit at an incredibly low 4.0 parts per trillion. To put that into perspective for a second, a single part per trillion is essentially one drop of water diluted into 20 Olympic-sized swimming pools. It is virtually nothing. They also set limits for other forever chemicals, like capping PFHS at 10 parts per trillion.
So to enforce these microscopic limits, the 2024 regulations laid out a really clear three-step process for public water systems nationwide. Number 1, they must actively monitor for these specific chemicals. Number 2, they have to be transparent and notify the public about what they find. And number 3, if the levels exceed those strict MCLs, the water systems are legally required to reduce the PFAS levels. To pull this off, facilities have to implement advanced treatment methods. We're talking things like Granular Activated Carbon, or GAC, which essentially traps the chemicals, ion exchange resins, which pull the PFAS out using electrical charges, or highly pressurized reverse osmosis systems to physically filter them right out of the water.
Which leads right into Section 5, the 2026 proposed rule updates, the regulatory roller coaster. Fast forward to May of 2026, and the EPA published a major announcement in the Federal Register outlining a comprehensive strategy update. It contained two massive proposed rules regarding exactly how they're going to handle PFAS in drinking water moving forward. The primary goal of these 2026 updates? To make absolutely sure that every single regulation adhered strictly and lawfully to the Safe Drinking Water Act. This new strategy creates a fascinating and honestly pretty sharp contrast. Rule 1 is all about the heavy hitters. It upholds those super strict 4.0 parts per trillion standards for PFOA and PFOS. But it offers public water systems a practical 2-year extension to actually comply with the rules. On the flip side, Rule 2 is basically a retraction. It proposes to rescind the drinking water regulations entirely for 4 other PFAS, including chemicals like Gen X and PHXS. Now, you might be wondering, why in the world would they tear up the rules for those 4 chemicals if they're so dangerous? Well, it all comes down to legal procedure. The EPA actually had to walk back the regulations on those 4 specific PFAS because back in 2024, the agency proposed and finalized the regulatory determinations simultaneously, in tandem. And under a clear reading of the Safe Drinking Water Act, doing it that way is an unlawful procedure. So to avoid massive legal vulnerabilities and ensure the regulations can actually survive court challenges, the EPA is essentially resetting the process for those specific chemicals so they follow the exact sequence laid out in the statute. Which leaves us at a pretty profound crossroads. As the EPA corrects its procedural missteps to build a legally watertight defense against these chemicals, we are left looking at the reality sitting right in our kitchen sinks. We know the devastating human toll, we understand the unbreakable bond, and we have the data showing it's in 45% of our tap water. Now, scientists are actively developing some amazing emerging destruction technologies, like using highly energized plasma or supercritical water oxidation to finally shatter that stubborn CF bond. But the ultimate question you should take away from this explainer today is this. As we navigate regulatory extensions and complex legal technicalities, how quickly can we actually mobilize to free our tap water from an invisible threat that was literally engineered to last forever? Thanks so much for learning with us today on The Explainer.